Hi kids, this is Ms. Nichols, and this review video is on the parts of a circuit and how to draw circuit diagrams. I want to give a quick refresher / overview of what's actually happening inside circuits. We'll come back to this in class, of course, but this is a good framework to build all the rest of the understanding of the circuit on. As you already know, electrons exist in every atom, so wires, batteries, and resistors, and everything else in the circuit already have electrons in them from the beginning. Before anything happens, the electrons are at a state of equilibrium. That means they're relatively evenly spaced, and they can sort of migrate through those conductors on their own. The spacing is important because that means that nobody has any electrical potential energy. We would gain electrical potential energy when we change the distribution of those electrons, force them closer to each other, or further from protons. When the circuit is closed, so when you make a complete connection between one end of the circuit and the other, a chemical reaction in the battery begins to push electrons from one side, the positive pole, to the negative side. We call these electrons energized because in that process, the chemical energy of the battery is transformed into electrical potential energy in the electrons, so they have more energy. Work is done on the electrons to put them in a state of high energy. And now these energetic electrons are trying to repel from each other because they're all piled up at one end of the battery. The other side of the battery, of course, has an excess of protons, and that's very attractive to the electrons on the other side, but they can't move backwards through the battery. There's chemical components called salt bridges that prevent electrons from going backwards through the battery, so they've got to find a different path to return to the positive side of the battery. Since we have a conductive path of resistors and wires connecting the negative and positive sides of the batteries, those electrons flow through the circuit to get back to the other side of the battery. When the electrons go through resistors, they transform some of their electrical potential energy into other types of energy that is useful. So that's kind of where the magic in circuit happens, when electrical energy is transformed into useful energy. There are four main parts of the circuit. We have the energy source, the resistors, sometimes called loads, wires, and switches sometimes in circuits. And we're going to be going through these individually in some more detail in the next slides. In a circuit, the energy source is the place that gives electrical energies to the electrons that are passing through. We talked about this as a battery before, but there's actually a wide variety of things that could be potential energy sources in circuits. Batteries are probably the easiest to manage and the most common. We're also going to be talking about capacitors in this class. And of course, there's wall outlets and solar panels and other things like that. In a circuit diagram, so kind of the shorthand way of drawing a circuit, typically batteries appear like that. Two lines, one of which is longer than the other. The longer end is the positive end and the shorter end is the negative end of the battery. Sometimes it looks like two batteries combined back to back. That's just called two cells of a battery. And capacitors, when they appear in circuits, are similar to batteries except the lines are the same length. So that's kind of a rotated 90 degrees capacitor schematic from a circuit diagram. Every circuit should have a resistor, sometimes called a load, in the circuit. This is the place in the circuit that transforms the electrical energy into useful energy. If for some reason there is no resistor in the circuit, it's known as a short circuit, and it's problematic typically because the energy doesn't have a place to go that's useful, and it instead transforms usually into heat, and it can melt or burn you. So in any case, it's important for every useful circuit to have a place for the energy to go. Some examples of resistors are light bulbs, toasters, motors, buzzers, and sometimes there are just something called a plain old resistor. The job of this thing is just to use up electrical energy, and the reason we have that in a circuit is because we sometimes have other components that are very sensitive and want a certain amount of electrical energy, and we don't have infinitely adjustable batteries. So what we do is we put a little bonus resistor in there that uses up some of the energy so that the component gets the correct amount without getting too hot or overloading. So that's just a regular resistor. Resistors in circuit diagrams usually are represented with a series of zigzag lines. Sometimes specific loads have different symbols. Light bulbs have different symbols often, but they usually sort of are obvious what they are, or they're labeled, or they have a little resistor inside them. Wire is a critical component in any circuit, which is just the conductive material that makes a complete circuit from the energy source to the resistors and back again. You should know that the wires themselves actually do have some resistance, so electrons transform some of their electrical energy typically into heat in the wires, but this is usually negligible compared to the amount of resistance of the primary load. There will be an equation that we'll learn later on to let you calculate the resistance of a wire with known dimensions, so you should sort of be looking out for that in the next couple days. Wires in circuit diagrams are easy. They're just lines that connect things. The last thing is not required, but often present in circuits, which are switches and buttons. These are used to open or disconnect a wire, or close or connect a different wire. And of course, they can be used to complete a circuit and turn resistors or capacitors on or off in the circuit. In your house, you have lots of switches, light switches, power buttons. The circuit breakers in your garage are pretty useful as well. When you see a switch in the circuit diagram, it usually just looks like sort of a gap in the circuit that could be connected. So in this class, we'll see how whole circuit diagrams can be kind of created and explain the observations that we notice in electrical systems. Typical electrical systems are complicated. When you actually go and try to do this in your house or create an electrical device, you'll notice that the wires are curvy and crazy and all over the place. However, usually circuit diagrams are drawn with nice straight lines and right angles just to make it clear. So one of the skills that you'll develop is transforming a crazy circuit into a nice, tidy circuit diagram. Thanks for watching.